what is infrastructure as code? Infrastructure as code is a concept that's really important in the DevOps world, where basically you get to describe the infrastructure that you need for your application as code, whether it's a YAML file, whether it's, it doesn't matter, right? You can describe it however you need to, and it's stored inside of the source control system. So when I'm talking about the infrastructure, these are like, if I have a web app, well, what type of server do I want? How much memory do I need? Do I need IIS? Things like that, right? Or if we're going into Azure and I'm using app service, what type of app service? Which region do I want to deploy this into? How big of an app service do I need? And how many slots do I have? Things like that. So that kind of describes what your infrastructure is. Now, the power of having this in your source control system right alongside your source is now everything is versioned together. Your source code as well as the infrastructure that you need. Now, where the magic really happens is when you use this infrastructure as code file in something like your CI/CD pipeline. So a typical example is we have ARM templates, right, that describe our infrastructure up in Azure. So now during our build process, we of course compile everything, we create our binaries, and then during our release pipeline, we take our ARM templates or infrastructure as code, and now we can on the fly either deploy a brand new environment that is described in this infrastructure as code file, or if it's already deployed and there are made changes in the file, it will go ahead and make those changes in your infrastructure for you and then deploy your application. So infrastructure as code, super powerful, super cool, very, very important concept in the DevOps world.
Hey everybody, it's your buddy Jay. I am back once again. You are watching AzureFunBytes, where what do we do every week? We get together, we have a conversation about the products, the services, the people that make up an amazing Azure experience. And so here we are this week. We're going to be talking about just that subject that our friend Abel gave us some information on. Infrastructure as code. So the big idea that we want to always think about when it comes to infrastructure as code is codifying, version controlling, and being able to repeatably deploy infrastructure every single time with a set of instructions. And so what we're going to do today is we're going to talk a lot about that. We're going to show you some tools that'll help you start codifying your infrastructure. And more than anything, we hope you're going to learn something. And to help me help you get started learning, I've got Alex Frankel. Hey, Alex, how are you today?
I'm good, Jay. Thanks for having me on episode 50. Very exciting.
Yes, episode 50. It's pretty great. We hit a milestone today, and I'm glad to have you part of it with a kind of a milestone product, if you will. Something where we've had ARM templates for a while, and we'll get into this in a little bit. We've had ARM templates for a while. We've had all the third parties that have provided infrastructure as code tools with DSLs, domain-specific languages. But this time around, we're going to talk about Bicep and how it is a tool for you to build just about anything you need to in Azure. But before I get to that, Alex, I want to show some stuff to our viewers real quick. One, if you haven't yet, please go to Microsoft Learn. That's aka.ms/LearnTV. I should say go to LearnTV and take today's poll. Today's poll is, are you currently implementing infrastructure as code for your deployments? I want to know. I think it's going to give Alex and I a good idea of what you're all up to, how many of you are actually utilizing this methodology. I think it's super important. And so while we do the show, feel free also in the chat window there, or whatever native service that you're using, to send in your questions for Alex. We've got this great opportunity with a program manager for the Bicep product to talk a lot about how it works, how to get started, things like that. So we've got a big agenda today, and I want to be able to get into it quickly. But before we get into the agenda, I want to ask a little bit about you, Alex. I don't really know a lot. We've only talked a couple of times before, but why don't you tell me a little bit about how you got here? Specifically, how did you get to Microsoft?
Sure. So I was a CS student at a small school in Pennsylvania, Lehigh University. If there's any NCAA fans or NBA fans, Lehigh was a 15 seed in March Madness one year, and they beat Duke, that's Lehigh's claim to fame. And CJ
Amazing.
McCollum, who's on the Trailblazers right now and is an all-star. I walked by him a couple times, so that was cool. So I went from Lehigh. I did an internship at Microsoft the summer before senior year, and then came right back. I had a good time, and I've been here ever since. When I started, we were working on some System Center products, which are still around and still an important tool. And then we started working on a product that's popular now called Log Analytics. And I was doing a lot of like front end design in the Azure portal, and we had our own portal at one time. We started working on policy. We switched from log analytics to policy, and that got us a little more into governance and modeling more things as code. We kicked off a project called Blueprints a few, maybe 3 or 4 years ago at this point. And that really exposed us to deployments and infrastructure as code for real. And I think we got an education really quick on how diverse this part of the industry is. And that eventually led us more into improving ARM templates. And that eventually led us to where we are today with Bicep.
Very cool. So it sounds like you've got a great kind of base of different things that Microsoft has kind of produced for Azure in the last few years to help put some training wheels around things, if you will, or some safety gates is a better way to put it. What do you think really provides, I guess, the most safety for people who are doing deployments? What do you think really provides them with the safest way to get started?
I think, when people start their Azure journey and they start their infrastructure as code journey, my guidance is always to start as small as possible and learn as much as possible in those early phases. I think sometimes people take on a little bit more than they can chew, and they try to deploy their whole architecture right from the beginning. And it's like when you're learning how to code for the first time. If you try to write your whole program right away and you run it and you have 75 different errors, you're like, how am I ever going to be able to do this? And I don't even know where to start. So working really incrementally and understanding thoroughly what you're doing at each stage, I think is the most helpful. So I try to tell people, really learn how Azure works and really learn how ARM, the Azure Resource Manager API works. Because once you understand that, you understand concepts like resource IDs and the scopes where resources lives, then you have a really thorough understanding of what's happening behind the covers. Even if you end up doing stuff in the portal or doing stuff with CLI or whatever, you have a good sense of like, okay, here's how this talks to that, and here's how I set up my permissions to make that conversation happen. And then you can always build on top of that. So as you mature, you may want to have custom RBAC roles so that people don't do the wrong thing accidentally, or have policies so that you can monitor what resources look like or prevent other behaviors from happening. So there's a lot of tools in the toolbox, but it all stems from having that kind of core understanding.
Great. So we got a big agenda today. And I guess the first thing to do is just to kind of, kick off what Bicep is. And so one of the things that I think is the best way to kind of think about it is it's an abstraction, if you will, from Azure Resource Manager. And I've got this great little diagram right here. And I think that this kind of says it all, is that essentially you are the author, you're writing a template, That template gets converted into JSON by Bicep, and then from there it goes to the Azure Resource Manager API and deploys your actual infrastructure. Did I put that all in kind of the right way?
Yeah, that was perfect. We sometimes use the term transparent abstraction, and all that means, because you're right, it is an abstraction. But we try to abstract away the things that we know we can kind of safely abstract and make things easier for you without limiting what we expose in Azure itself. So you have all these teams innovating. There's hundreds of teams in Azure that are creating new resource types or new features or what have you. We just want to make sure that we're exposing that to you as easily as possible. And so that's why we use the term transparent abstraction, is we're not ever going to hide new resource types or new API versions, but we're going to present it to you with a user experience in your editor that's a lot easier to wrap your head around and a lot easier to debug and do all these sorts of inner loop kind of activities. We just want to make that as easy as possible.
And I think that kind of like debugging, troubleshooting, and even because everything's been made into code, creating tests around. So actually using software engineering or software
practices,
concepts, practices, these concepts that you would use for your software delivery, you could use them and apply them to the infrastructure delivery. And I think that that's one of the big reasons why I think it works. It makes sense to me. So the first big question I want to ask you, why are we investing in Bicep over just really solidifying ARM more, ARM templates more?
Yeah, great question. So I mentioned, we were on that journey from blueprints to ARM templates to Bicep. When we kind of started working on ARM templates and putting some more energy and more focus into that, because it hadn't gotten, I think, the investment or that the team thought that the investment that it deserved for how important it was as like a foundational tool of Azure. So I think sometimes ARM templates get a bad rap and they don't have like the mind share that I think that they used to. But in terms of like how much it's used to deploy Azure resources, it's like by far one of the most popular tools for deploying Azure, if for no other reason than historically, but it also is a really powerful tool. So we really wanted to invest in ARM templates because there was just a lot of love that it needed. And one of the first things that we did was kind of reinvest in the ARM template VS Code extension that was out there. It provided like some basic schema validation, as well as some IntelliSense capabilities that we had built up over the years. But we started investing in that and just adding like syntax highlighting was one of the first things that we did for ARM template tools, which, those things made a big difference. And we saw a lot of a reduction in error rate and those sorts of things for people that were using the tooling. But we kind of realized quickly that there was going to be only so much that we could do with that. And so we started kind of reevaluating the landscape of like, what if we wanted to make a big jump and make things much better? And we started looking at a lot of different options. And we looked at, kind of like there's Pulumi that is out there where you can write your infrastructure as quote unquote real code, although I take objection to what's real code and what's not real code. But there's that kind of approach of writing in a higher level programming language. We talked about, modifying the JSON schema to see if, like, without having to totally reorient people, can we make things a little bit better? So we did a huge, I think the biggest research effort I've done in my career here to make sure we were thinking about things in the right way. And then we had this kind of lingering option of like, we could do a new domain specific language, and we know, there's a lot of like dragons in that direction where things could not go in a great direction. But we thought it was worth it to take that chance and really invest in the language. And that's what really drove us to Bicep. So that's why we're doing it, just because there's a huge customer base that's using ARM templates. And we felt if we could just make their lives better, putting aside all the other options that you have for deploying to Azure, we can just make the ARM template customers more efficient and more successful. That in and of itself is worth investing in. And I think, one of the maybe misconceptions about ARM templates is when we launched Bicep, they're like, why, people said, why are you doing another language? Maybe you don't want to do that. And I think the misconception was that ARM templates already were a language or a DSL. It was just locked inside of a JSON file. And really all we've done with Bicep is give it its own space to live in, and instead of having to fight the kind of JSON parser that exists out there.
And for people who may be learning about it, domain-specific languages, I've got a link at the bottom. Those are specific programming languages, whether they're native like Bicep or maybe general purpose like Chef is using Ruby. I think you can write your Pulumi stuff in Python. You're basically using this language to assist in what you're actually building. Big differences I'd like to hear. Now, I'm going to bring up this. This is the Bicep Playground. And the Bicep Playground is essentially a great place to kind of see one-to-one, I think. Mm-hmm. Can you talk a little bit? I mean, I can see right from the beginning by two things. One, I can say my key differences between the two is that one kind of is more readable, and far shorter, because on the left we have our Bicep template, on the right we've got our ARM template, and you can see that there's a big difference in the lines of code that you're actually writing. Aside from just that basic stuff, I mean, I see you're not establishing the schema in there because the Bicep file type is just recognized as its own kind of language, so you don't have to specify a schema. But other than that, what are some other key differences that you'd say are there between the two?
Yeah, so what you mentioned around just the syntax being cleaner and easier to read is certainly a key difference. And what I mentioned before is by embedding the ARM language inside of a JSON template, you basically have to add all this like goo to make sure that we can process the file as an ARM template. So you have to have a special schema because JSON files can have a schema, and that's how we powered a lot of the tooling. And then you see double quotes everywhere because that's just JSON. It is what it is. And then in order to have like expressions so that you can have a resource group function and a concat function and all these sorts of things, those had to be embedded inside of JSON string values. So that's why you have the double quote, and then you have the open bracket, and then that's when you're like in the ARM template language. So you had to do all this ceremony to do basic stuff. And with Bicep, you don't need any of that boilerplate because we are domain specific and we know what you're doing. We can make things just a lot terser, easier to read, and so on.
So if we're talking about big differences as well. What would say be the biggest differences, say, between this and HCL or Chef writing in Ruby? Is there a big difference in the language itself as far as how it's modularized, how strings are done? Is there any big difference between it?
I think there's definitely similarities in some of the DSLs, and we take inspiration, like any good tool, we take inspiration where things have been done well, and we try to build on that. One of the things that I think sets Bicep apart from ARM templates, and I think sets Bicep apart from a lot of the other kind of DSL-y, config-y type languages that we might be used to, is Bicep was really built. The foundation of Bicep is really built more like a traditional programming language. So even though it doesn't look like a quote unquote traditional programming language, when you use Bicep, and we hear this a lot anecdotally, which makes us feel good, is it feels like a modern language in terms of the IntelliSense and the validation and all these sorts of things. And that's not an accident. So we thankfully have access to like preeminent language designers here. So there's a guy named Anders Heilsberg, who your viewers may already know, who helped design C# and TypeScript. And he's given us a lot of tremendously helpful advice on how you actually build a language and what makes building a language hard. And one of the best pieces of advice that he gave us is, when you're building tooling, you're designing it so that it can fail gracefully all the time in the weirdest possible combinations of situations. Because when you think about it, when you're authoring code, 99% of the time, the code is wrong because you're authoring it. You're in the middle of the process. If the code was complete, you wouldn't need the tooling at that point because it's done. You would send it off, you would get a response, and maybe it would work, maybe it wouldn't. But when you're editing, it's always going to be wrong. And so the thing that takes the most energy and engineering effort in building this tooling is making sure that it can fail gracefully. So you can have an error on line 2, but still parse the rest of the document correctly. And you can still always get IntelliSense, and you can always get validation. So I think the biggest difference is that tooling experience and the feedback that you get. And we're seeing, tremendous benefits from that. We're starting to get a picture of, like error rate between ARM templates and Bicep. And we're seeing a really dramatic, I think, way more than we thought we could deliver with Bicep because the tooling is so rich and so complete. And the other thing that we do is, and that I think makes Bicep really effective, is we build the compiler and the tooling at the same time. So whenever we're coming up with a new syntax, you have to account for the tooling experience at the same time, and we won't ship until the tooling aspect of it is done. And the compiler and the editor are the same code base. So if you have an error in the editor, you'll get that error in the CLI, and vice versa. And so that can give you a lot of confidence in your kind of day-to-day authoring.
Sure. And so I'll ask you one more question, and then I'd like to remind everybody about a few things, and then I'd love to kind of jump into what you'd like to show me today. My big question is that how do you stay connected with product teams around changes so that anything that is supposed to go into, say, ARM or Bicep, that's maybe a new service, new options, changes in the way the service is deployed. How do you kind of stay in touch with all those people to actually find out about what's coming downstream?
Great question. The short answer is it's impossible. There's too many teams doing too many things in Azure. There's no funnel, not really, where you can get a sense of like exactly what a new resource is going to do and make sure that it's been implemented in the right way and in the right place. And so the way that we deal with that is we try to make sure that Bicep works in the most Azure native way possible. And all that means is we mentioned we're a transparent abstraction. Anytime a new API exists in ARM, it automatically works in Bicep. And if when resource provider teams, when they come up with a new resource, part of their process is to publish, it's called the Swagger specification. So if you've done Swagger specs for APIs, it's exactly what our teams do internally. They publish these specs, those specs are publicly available. And the way that we build up our types, the available types in Bicep, is by processing those Swagger documents so that we can give you a rich IntelliSense and validation experience without forcing the teams to do extra work. So with almost all the other tooling in Azure, there's some process that has to take place. A portal UX has to be lit up, or the CLI client has to be generated, or something has to happen. With Bicep, there's nothing that you have to do. And so you can always be basically guaranteed that if it can happen in Azure in the API, it can happen in Bicep, which is a really important thing that makes Bicep unique.
Gotcha. And so I know that there's a Bicep repository that you can go to on GitHub. It's under the Azure organization. And what I'm curious about it, you're doing all this in open source, am I right?
That's right. Yeah, I mean, it's all open source. I hope to never do a closed source project again for the rest of my life, because it's been so empowering to just lay it all out, right? As soon as we think we're going to do something, we get to create an issue and get feedback. And if we're really wrong on something, we know about it way faster than if we had stayed in our little factory and tried to ship something and then found out it was not right. And then it's too late at that point, right? Nobody wants to redo work that they just did. And so being able to get that feedback early and keep those communication channels open it's just been instrumental in our success so far, I think. So it's the way to do these projects for sure.
Great. So let me give you a second, and I want to tell everybody a few things just to remind them. One, if you haven't yet, please head over to Learn TV and take our poll, aka.ms/LearnTV. We're asking, are you currently implementing infrastructure as code as your deployments, for your deployments? That's a really useful place to go. Learn TV to find shows like this and a ton of others. And then I'd also like you to go and check out the Bicep documentation, where you can find out even more about Bicep. There's this great introductory video from Brendan Burns about the next generation of ARM templates. I really recommend you check it out. It's also got some just benefits over other tools. Really think that if you want to start jumping into Bicep, you can run and grab all that information and really take advantage of it. And the other thing that I think is really useful is there's the VS Code plugin, which is, or I should say extension, for Bicep. And I think it's really one of the most important parts. And I think you're going to talk a little bit about it. I know that there's all these ways of implementing this extension to make life easier. Like I showed this before, the fact that you can just peek at references and add just about any type of resource, it'll just automatically kind of get discovered, if you will, as soon as you just type resource AKS, and you can see we can start saying we wanted a managed cluster. I think this is all really useful concepts and tooling to make sure that when we actually are using Bicep, we have a great experience.
Yeah, exactly.
Awesome. So I'd like to give you some space to kind of show us a little bit of what exactly you want to today, as far as what Bicep is, how to get started with it. So when you're ready to, let me know, and I'll put your screen up, and we'll get started with your presentation. And I want to remind everybody, if you're watching and you have questions, use your native chat. Use the Learn TV chat. Send us in your questions. We'll make sure that we get to them as quickly as we can.
Cool. I'm ready when you are. Is the screen sharing going?
There we go.
Awesome. Okay, so getting started with Bicep is super easy. We're in VS Code. You can do everything from here. I have some tools pre-installed, but I can show you how to install them anyway. So you need two things to get started. One is the Bicep CLI, which is what actually transpiles your code. So Jay, you mentioned that you go from Bicep code to ARM template code. It's just like going from TypeScript code to JavaScript code. That's called transpiling. Some people say compiling. It more or less means the same thing. So the Bicep CLI is what's doing that translation for you. If you have the Azure CLI installed, which many of you probably already do, there's an AZ Bicep command group there pre-installed, or it's bundled with the AZ CLI. What you can do is you can, if you want to just install it, there's an install command. But when you run AZ Bicep, if it's not installed, we'll just get it for you. So most of the time, you don't need to think about installing the CLI. It'll happen in the way that it needs to happen. We'll put it in the right spot so that everything kind of works correctly. So if I do
available in Azure CLI, or if I'm right, you can actually download the Bicep binary itself and put it locally if you wanted to.
Yeah, exactly. So you can do, if you're on Windows, you can do Choco install Bicep. I think we're in the Winget repositories as well. These are both open source contributions maintaining these packages in Chocolatey and Winget. So we really appreciate those sorts of things from the community. So you can get it and install it locally on your path. And if you want to use Bicep with PowerShell, the installation is a little different. You need to take care of the installation yourself. And so using some of this command line tooling, or you can use Homebrew on Mac to just get it on your path, and then PowerShell will talk to it directly. So you can do kind of the same experience in PowerShell.
I'm running a Mac, and I went ahead and hit just brew install Bicep, and there it was.
Yeah, exactly. And then the other thing that you need, so in VS Code, you mentioned the extension. The extension is critical. Right now, we're only in VS Code, but the package is generic. Basically, we implement something called the language service protocol, or LSP, and that makes it so that everything's self-contained. And if you want to run the language service in another tool, you can do that. So someone in the community got it running in NeoVim, which is awesome. And so if you can get it to run there, you can get it to run anywhere. And so we'll try to extend it out to other IDEs or editors in kind of a native way, but if you need to get it running, you can do that. We focus on VS Code since it's cross-platform and pretty universal at this point. So you'll see in the bottom right corner, I have the Bicep language that just gets auto-detected from the Bicep file extension. But if you need to go and install it, you can just search for Bicep. And you'll see it here, and you can just install it from there. And this walks through some of the features that I'm going to walk through as well. And so that's literally all you need. Now you're ready to go. It's pretty straightforward.
Gotcha.
We can start. The best way to start is the absolute basics. And what are we here to do? We're here to deploy resources. So before we get into any advanced features or anything like that, let's just author kind of a basic resource. So you mentioned this earlier. I just start typing resource. If I don't know what to type, I can just do Control Space and I get some options for what I need. I have some snippets here if I want the tooling to kind of help me build this out. I'm going to start with, we need to give the resource a symbol name. This is just a variable, so I could call this foo. I could call this my app plan. I'm just going to call this plan for now.
Okay.
And then the third segment of a resource declaration is the type. And these are all the Azure types that are available in ARM. And
so it's just all the APIs, just a list of all the accessible APIs that you can use to create different services.
Yep, exactly. So if it exists in the Azure API, it's going to show up in this list. I can scroll through this whole thing if I want to, or I can just start typing the type that I want. So the type that I want is called server farm. So if you know web apps in the portal, I think this is called app plan. Sometimes I forget, this name has changed a few times, but at the API level, it is called server farms. And then once I've picked the type, I need to pick the version. And the versions in Azure are all date strings. Sometimes you might see semantic versioning for other APIs, but for Azure, we use date strings. And this versioning is really important. You know, we sometimes get the ask of, I don't want to worry about the version. Can you just pick the latest for me? The concern with doing something like that is if we pick the latest and we upgrade you kind of silently in the background, we will introduce breaking changes without you being ready for them. So even though the versioning can be a little ugly and a little verbose, it's a really important construct to make sure that your Bicep code works today and works 5 years from now. There really shouldn't be any issues in the future as long as we pin to a specific version. And then I'm going to do equals, and then I have a few different options here. So we'll hopefully get to maybe some looping examples and some condition examples. But the one I'm going to pick here is required properties. And this will fill in what Bicep knows as the required properties for this resource type. Now, because we're having a casual, low-key conversation, I'm airing a little bit of our dirty laundry of how all these types get generated. Sometimes the Swagger specifications are wrong. Sometimes, for technical debt reasons or legacy reasons, these Swagger specs are not as accurate as they could be. And one of the things that we're excited about with Bicep and kind of reacquiring some of this mind share is making sure that the teams care about their Swagger specifications, because we build not just Bicep tooling with those Swagger specs, but the CLI we auto-generate, the Terraform provider we auto-generate, all with the same source document, so that your experience across all these tools is the same. So there are some more required properties here that I happen to know. But if the Swagger spec is right, then we do a really good job of just slotting in all these required properties for you. So I'm going to give the app plan a name. So I'll say a.frank app plan, and I'm going to give it a location, and I'm going to just use the resource groups location. So this Bicep code is eventually going to be deployed to a resource group, and so I can just pull that information in dynamically. And this is the equivalent in an ARM template of doing double quote, bracket, resource group, dot location, closing bracket, double quote. So we're getting rid of a lot of that noise. And one of the bigger reductions, you mentioned the lines of code reduction, which we are definitely doing. We're also doing a huge number of characters reduction. So we're seeing anywhere from like 40 to 60% less characters needing to be written to express the same information. And that's really helping to contribute to the readability. When I do control space, I get all the other properties that are available for this resource type. So extended location is like a brand new property that's for Arc enabled clusters. We're not going to do that today, but you can see that as soon as a new feature is lit up, this was announced at Build just a couple months ago, we can make that available in Bicep really easily. I'm going to add a kind, which I happen to know needs to be Linux for what I'm going to do today. This is another one where we want to make sure those specifications are accurate, because if they are, we can provide the list of values here as well. But for now, we're just going to type in Linux. And then the other thing I want is a SKU. The SKU is an object, and then Bicep knows about all the different properties that are in the SKU. I just need the SKU name, and I happen to know that I want B1, which is a basic SKU. And then most resources have a properties body inside of them. So I can just do properties, and then I can do control space. And these are all the properties that are unique to this resource type and API version. And you can see we just expose everything. And what I want is the reserve property, and I get a description here that I need it to be true for a Linux plan. So I'm going to say reserve true. And now I have my basic resource definition. And it's fairly straightforward. And you can see it's a really good way just to explore, what does this resource type even offer me? What properties exist, and what do those properties do? And we pull in all the descriptions and stuff like that to make it as easy as possible to kind of ramp up on any new type, and not have to go to documentation and flip back and forth and save you some time there.
So you're building things rather than spending your time reading specs, understanding like the actual language is a little bit easier if you're actually writing it, it seems.
Right. And we talked about earlier about, starting small and understanding what you're doing. Those sorts of things where you can explore a resource type and explore the descriptions all in the editor experience really help you build up that context and that rich understanding as you're authoring. One of the next things we'll do, and if you're used to ARM templates, you're used to this kind of thing, is, we don't want to hard code everything, right? We want this ARM or this Bicep code to be dynamic so that we can hand it to someone and they can just fill in a few values, and then they can be ready to go. So let's do
variables, right?
Exactly. So let's do a parameter. So param is just the shorthand for parameter. It follows the same structure as a resource declaration. It's always keyword, symbol, whatever symbol you want, and then the type. So the name for this param, we're going to say name prefix, and then we get the types that we can set this to. So we're just going to make this a string. And what I'm going to do is leave this as is. If I wanted to, I could set a default value. So I could say this is a.frank if I wanted to. But what I want is for it to be required. So I want the user to have to pick a value and know what value they're picking. So I'm going to leave that as is. Now, you'll see I'm getting a yellow squiggly here, and we can hover over it and see what it's complaining about. And it's just telling me, hey, this parameter has never been used, so it's not doing anything, even though I may have thought it was doing something at this point. So I need to use it somewhere. And that's our linter that's running for Bicep. And being able to provide a linter and being able to provide all these features is because, I mentioned that we're built like a programming language. Mm-hmm. That's what allows us to extend the functionality of the language fairly easily. We turned around the linter pretty quickly because everything is kind of built in the right way from the very beginning. So I want to use this name prefix, so I get that yellow squiggly to go away. In ARM templates, the people watching this may be used to like the concat function. So they would have had to do concat, and then they would do name prefix, and then comma, and then some string. We don't want people to have to type concat. You can if you want. But what we can do instead is have string interpolation. And the linter is catching this one as well. They're saying use string interpolation instead of the concat function, and actually providing me with a quick fix to change that code for me. So if I do the quick fix, I get a preview of what it's going to be, and it'll swap it out correctly. And this is common in most programming languages to have some sort of interpolation capabilities, and it makes everything a lot easier to read for the next person that's going to have to edit this code.
Sure.
The skew, we may want to make that a variable or a parameter. So I'm going to make it a parameter in this case, and when it's a parameter, users can override that. Whereas if it's a variable, it's in the code itself, and so you need to edit the code to make that change. So the parameter makes things more dynamic. And for this one, I am going to set a default because I don't want to have users have to worry about it unless they want to worry about it. And so we'll set the skew to be the skew name. And this is, again, the equivalent of having to do double quote, open bracket, parameters, skew, all that sort of ceremony. You can just use expressions anywhere, pull in parameters and variables from anywhere, and so on.
Very cool.
And the last thing we'll do on this file is output some information. So often when we're creating these resources, there's some critical piece of information that we want to omit so that it can be picked up in a pipeline or picked up in another file to do whatever needs to be done. For the app plan, the crucial information is the ID of that resource, because I'm eventually going to create a website and I need to know the resource ID of the app plan in order to wire those things together. So I'm going to use the output keyword, and I'm going to say this is plan ID, and it's going to be a string, so same structure. And I'm going to say it's equal to, and then I get IntelliSense. I'm always getting IntelliSense. And I'm going to say plan, and then I'm going to do dot property access. And then I immediately get all the different properties that I can pull in from this app plan. In this case, I just need the ID. But if I needed something more complex, I could go into the properties, and I can do dot property access here as well. And I see all the different properties that the app plan exposes. And this is a slightly different list than when we were looking at the properties over here on line 11, because these are properties that I can write, whereas these can also include read-only properties. So a lot of times, like storage account URLs or other properties that only are known once the resource is created are read-only properties, and we can show those here as well. This is one of those things that we weren't able to do in ARM templates, but that we can do in Bicep, and it's a really nice experience for being able to wire these things together.
Very cool. And I just want to remind everybody, and while you're finishing up your template, we've got about 15 minutes to go, which I mean, it sounds like, you've got so much more to show us, but, time flies. But I want to remind everybody, if you've got questions, make sure you put them into the chat, whichever chat you're using. We want to hear what you're curious about. Anyway, Alex, why don't you continue?
Okay, sounds good. So this is, like a typical Bicep file. It happens to just be deploying one resource. I could deploy 100 resources in here if I wanted to, but let's just keep this one simple. And what we're going to do next is actually create another file, and we're going to call this main.bicep. And this is actually going to be our eventual entry point to deploying this code.
Okay.
We're going to add a couple new concepts here. The first one is a keyword called target scope. So I mentioned, learn ARM, learn resource IDs, learn scopes. Scopes is a really important concept in Azure. There are 4 different scopes, 5 if you want to get technical, but there's the tenant scope, the management group scope, the subscription scope, and the resource group scope. And we expose those sorts of details in Bicep as well. So I can pick which scope basically I want to target this Bicep code to, because that dictates what features light up, what resources I can declare, and so on. For this one, I want to target the subscription. And the reason I want to target the subscription is I actually want to create the resource group as part of this Bicep code.
Okay.
So now that it's a target scope of subscription, let's create the resource group. So we're going to do resource. We're going to just call it RG, and we'll search for resource group. We'll pick the most recent API version, and then we'll do the required properties again. This one's accurate. And then the name is going to be a.frankrg. And the location is going to be, we want to be dynamic with this stuff. So there's a function here called deployment. This is a little trick. This function is the metadata of the deployment itself. And that exposes some properties. One of those properties is location. So I don't need to hard code the location is the point. And now that I have a resource group, I want to deploy things to that resource group. And so I want to deploy that app plan to that resource group in addition to some other things. What I'm going to do is use yet another new keyword. So this one's called module. And a module is a concept in Bicep. And the idea is any file can be a module. And just like modules in any other language, it allows for sharing of code between files and for code reuse. So it can be a collection of 0 or more resources, and it's a way of kind of instantiating that in this other file. So I want to say this is called plan deploy, and then I get some options of which file that I want to bring in. The file path is kind of like the type of the module is how we think about it. So it follows that same structure of keyword, symbol, and then type. So I'm going to pick the app plan keyword or app plan file, and then same exact idea, right? I have this required properties here. I can fill in everything all at once. I'm going to do this one a little bit slower so we can walk through the different elements of a module. I have a name. So modules have names. It doesn't really matter too much what the name is, but it has to be something that's unique for this file. So I'm going to just call this app plan deploy. I can add some parameters. So let's fill in the parameters that are required. So I have the name prefix and the SKU, and you'll notice this is the same parameters that we set up in the other file. So when I'm wiring these things together, it's really easy to know what I need to fill out. So I'm going to say the name prefix is a.frank. If I wanted to override the SKU, I could, but I'm going to just leave this alone. But I'm still getting yelled at by the editor, so let's see why we're getting yelled at. As a specified module is missing the scope, and we've talked about scope a few times. basically what this is telling me is this module is expecting to be deployed to a resource group because it's an app plan, right? App plans can only exist in resource groups. But the target scope for this file is a subscription. And so there's no way to deploy this module to a subscription. It needs to be deployed to a resource group.
Sure.
We happen to have just created a resource group. And if I start typing scope, it knows that the type of the scope needs to be resource group. And then I can just use that symbol, that symbolic name for the resource group, to say that I want this module to target this resource group. And that's it. So that all this code that we wrote is going to be instantiated as part of declaring this module. And if you have some really, heinous Bicep code that you want to kind of put off in a separate file and manage separately, you can put it all in that file and expose it as a module and only expose the parameters that are important, which are usually just a handful of values. And so this makes these files a lot more approachable than what you would have had to do in ARM templates, where this kind of thing gets really complicated really quickly.
Sounds good. So we got about 10 minutes left. I definitely want to see. So let's put this together.
Mm-hmm. Do you want to do a deployment? Is that how we're going to put it together?
Oh, I was just saying, is this like basically all we need to actually get our deployment going, at least for creating a resource group and I guess an app service plan?
Yeah, let's add one more thing. I have one more trick, sure. And then we can walk through how I would deploy this code. It should only take a few more minutes.
Sure.
So the last thing is, I have this web app, I have this app plan, I have a resource group. I have yet to declare a website, which is at the end of the day what we're all here to do. I happen to have this old ARM template that deploys a website, but it's an ARM template JSON. It's not Bicep code. And while we're actually working on some features so that you can use this JSON natively in Bicep, as of now, it all needs to be Bicep in order to use it. So what I'm going to do is I'm going to convert it from JSON into Bicep using something called the decompiler. So within the AZ command in the Bicep group, I have a decompile command. And I can just do -F and point it to that file and hit enter. And it's going to turn it into, hopefully, an equivalent Bicep file. So it's a really great. Go ahead.
Oh, I'm saying, there you go. Wow.
Yeah. So super easy. I'm going to bring this into my main directory, and I'm not going to touch anything. So I'm going to leave this as is. And I'm going to declare another module to actually deploy the website. So I'm going to say module, app deploy, and I'll say site. And I'll fill in all the required properties so that this goes a little bit faster. The scope is going to be RG. The name will say site deploy. And I'm just tabbing through. App plan ID is the cool part of what we're about to do. So I need to wire this website to this app plan. And in order to do that, I'm going to get an output from that module. So I'm going to say plan deploy, which is the name of that module. And I'm going to say dot outputs to get all the outputs that it exposes. And then there's my output of my plan ID. And now these things are wired together. I need a Docker image, because if we're going to do a container-based deployment, which is a nice way to deploy these things, just nginx demo /hello, and then the tag is going to be latest, and then a name prefix just like before. We'll use the same name prefix.
And if you were doing, say, an ACR, you could actually get your ACR here and then have your outputs for your ACR specified in the Docker image. Am I right?
Exactly. So what a lot of people will do is that ACR is usually already existing. They're not creating the ACR as part of this. So what they'll do is they'll get a reference to the ACR. So we'll do something like this: resource ACR, container registry registries, and then there's a keyword that we have called existing, which is to get a reference to an existing ACR.
Gotcha.
And I need a scope, and we'll just say RG. This is not accurate because I don't have this ACR, but I could do something like here where I can then get credentials from the ACR to then pass into the site, which I don't happen to have here. But that's the kind of wiring that I could do, and I could pull properties from it just like any other resource.
Sure. All right, we got about 5 minutes left. Let's bring it home.
Deploy something. So we're going to just use the deployment commandlet. So I can do AZ deployment create. These are the same commands that anyone who's using ARM templates is using today. And instead of having to turn it into the JSON, I can just reference the Bicep code directly. And the AZ CLI is smart enough to know to turn it into JSON on my behalf. I'm going to pick my resource group. And then I can actually do what if. So I can predict what this template is going to do before I actually have to go through with it. So I did, I want deployment sub create. We're doing to the subscription. And we'll do East US because I'm from New York originally.
Brooklyn here.
Nice.
Not originally, but I'm in Brooklyn right now.
That counts. Oh, and I don't need a resource group, of course.
Oh, yeah, because you're creating one in there. Gotcha.
Right, exactly. And so now what it's going to do is it's going to take the Bicep code, turn it into an ARM template, and actually talk to Azure and say, does this resource group exist? Do these resources exist? Do the comparison, and then give me a prediction up front of what it's going to do. And when this comes back, I can just say go or don't go, and then it's just a regular deployment at that point.
Is there a big difference between like the command? Like I think I was using AZ group deploy.
Those are our older commands. So hopefully you got a warning that we want you to move to AZ deployment, because AZ deployment is where all of our other command groups are. So you can do AZ deployment group, AZ deployment sub, AZ deployment MG, and so on. So it just keeps it all self-contained.
And so everybody knows right now what's going on is that that deployment is going to Azure Resource Manager. Azure Resource Manager is looking at what the transpiled or decompiled, the transpiled actual Bicep template looks like in ARM, and then taking that and saying, all right, let's create our resources. And then one by one, and I believe it's within, is it in the specific order, or does it do everything in parallel?
So it does everything in parallel unless it can't for some reason. So Bicep is smart enough to know that there's a reference between plan deploy and app deploy because of this symbol reference here. So it'll know to deploy the plan first and then deploy the app once it's done.
And obviously the resource group, which gets referred to, that knows that it has to create that before it actually creates everything else. I understand.
Yeah, exactly.
Very cool. So, hey, we've got about 3 minutes left. Is there anything else you want to show me in a minute before we kind of get, and there we go.
Yeah, so this is just our prediction. It's saying that, hey, we're going to deploy new things, which is exactly what we would expect to see. And then I can just click yes, and it'll start the deployment. We don't need to wait for this paint to dry. You can hopefully trust me that it's going to deploy successfully.
Sure. So it's like a Terraform plan, if you will.
Yeah, very similar idea.
Very cool. So, hey, you know what, Alex? We're just about at the end. And so I wanted to remind everybody, we had a poll today. It looks about 75% of you are using infrastructure as code, and that's great. That's what we want from you. We want to make sure also you check out all these different docs, check out the actual Bicep VS Code. You can go ahead, head up there, just click install. You can see it's moving pretty quickly. Almost every month since March, there's been an update. So definitely keep your eyes open. Alex, as we head to the very, very finish line, I wanted to ask, is there any way people can kind of keep tabs, find out what you're up to, where you're going to be doing any presentations or anything like that?
Yeah, so the best way to keep in touch is to keep an eye on the GitHub repo. So you can star the repo or watch the repo if you're adventurous, but there's a lot of activity. And then you can follow the Twitter account for Bicep. It's at Bicep Lang, and we're pretty good about keeping things up to date there. We have community calls that we're about to start. We're doing the first one next week, and we have a GitHub issue where you can request topics that we can cover. So we really like keeping the communication channels open. Like I said, that helps us build better products at the end of the day. So no one should hesitate to reach out. I mean, if you're a small company and you're getting started, we'd love to talk to you. If you're a big organization, we'd love to talk to you. So yeah, please do reach out.
Great. So thank you so much, Alex. I really appreciate your time today. I really enjoyed learning more about Bicep. And if you've got more to show, please, and there's so much more to Bicep than what we've seen, please let me know. I'd love to have you back again. But until then, let's give everybody the good wave goodbye, the big wave. Thanks for watching, everybody. We'll catch you next week where we'll be focusing more on ARM templates themselves. So you're going to get the whole gambit of how to build with Azure. So we'll see you next time. Take care.